Hello everyone and welcome to today's tutorial. In our previous tutorial, we looked at the broad concept of upthrust in fluids. Today, in this tutorial, we are going to solve problems. So let's take our first problem. It reads, block of material of volume 20 cubic centimeters in density 2.5 grams per cubic meters is suspended from a spring balance with half the volume of the block immersed in water. What is the reading of the spring balance? So this is our question. How do we solve it? First of all, let's have an overview of what the question is about. We have been told that the block has a volume of 20 cubic centimeters. So let's write that down. Also, we have been told that the density of the block is 2.5 grams per cubic centimeter. These are the two main information we have been given about block. Now, we are also told that the block is being suspended at spring balance. This gives us the idea that the weight of the block in air is being measured by the spring balance. Then it is now immersed in water with half of its volume in it. We know from Archimedes' principle that when a body is immersed in a liquid, it will experience an upthrust, and the upthrust will result in the reduction of the weight of the object. And so the spring balance will record a different weight of the block while in the water than when it was in air. And so the demand of the question is actually to find the weight of the block while in the water. That will be the reading of the spring balance. So let us continue to note that the volume of the block in water will be half of the volume of the block. We are going to get 0.5 times 20 cm cube, and this will give us 10 cm cube. We know from upthrust that when a body is immersed in a liquid, it will experience an upthrust. And this upthrust on the block will be the difference between the weight in air and the weight in water. So we can write that the upthrust on the block is equal to the weight in air minus the weight in water. So from this particular relation, we can find the weight of the block in water. So we are supposed to do two things. First of all, we are supposed to find the weight of the block in air and then find the upthrust on the block. Then we can find the weight of the object in water, which is the reading of the spring balance. Okay, because we have been given the density of the block in grams per centimeter cube and the volume also in cubic centimeters, let us maintain our answer in grams and in cubic centimeters. In this case, we can write that the mass of the block in air would be equal to the density of the block times the volume of the block, instead of dealing with the weight. So we are going to have 2.5 grams per cubic centimeters times 20 cubic centimeters. And this is going to give us 50 grams. So the weight of the object in air corresponds to its mass in air, and the mass in air is 50 grams. In other words, when it was first suspended by the spring balance, it weighed 50 grams. Now we want to know the mass or the weights recorded by the spring balance as it is immersed in water. So now that we know the weight of the block in air, which is the same as the mass in this case, now let's proceed to find the upthrust on the block. We know that the upthrust on the block is equal to the weight of the water displaced according to Archimedes' principle. Archimedes' principle states that an object is partially or fully immersed in a liquid, it will experience an upthrust, and the upthrust is equal to weight of the liquid. Weight of the liquid displaced is given by the density of the liquid, in this case the density of the water multiplied by the volume of the water displaced multiplied by the acceleration due to gravity. Once again, because we are dealing with the mass, let's divide both sides by the acceleration due to gravity, so that we are going to have the density of the water multiplied by the volume of the water displaced. And it means we are now going to get the upthrust on the block in terms of only the mass of the block. So by substituting in the values, we are going to get 1.0 grams per centimeter cube multiplied by 10 centimeter cube. This is what we are going to get. We are going to get 10 grams. So the upthrust on the block is 10 grams. So let us go back to the equation that we wrote. Remember, we wrote that the upthrust on the block is equal to the weight in air minus the weight in water. Now let's substitute in the figures. We are going to get 10 grams is equal to 50 grams minus WW. I'm making WW the subject. We are going to get WW is equal to 50 grams minus 10 grams. Our final answer is 40 grams. So the mass of the block in water is 40 grams and is the same as the reading on the spring balance. Now let's take our second question. It reads, a solid of mass 200 grams in air has a mass of 160 grams when partly immersed in a certain liquid. If the relative density of the liquid is 0.80, calculate the volume of the solid immersed in the liquid. And the density of water is given as 1 grams per cubic centimeters. If we analyze this question carefully, we realize that it is almost the same as the first question. The only difference we have here is that instead of giving us the density of the liquid, we have been given the relative density of the liquid, which means we have to find the density of the liquid and use it, but the principle is same. Also, instead of giving us the weight, we have now been given the mass straight away. So let's see how we are going to solve the question. First of all, we know that the mass of the object in air has been given as 20 grams, and the mass of the object in the liquid has been given as 160 grams. And we must expect that because from Archimedes' principle, when an object is immersed in a liquid, there will be a reduction in the weight. We have also been given the relative density of the liquid to be 0.80. Now, what is the principle we are going to use to solve this question? The question is asking us to find the volume of the solid which is immersed in the liquid. So here the question has told us that the solid is being partly immersed. We know that the volume of the solid being immersed in the liquid will be the same as the volume of the liquid that will be displaced. So if we're able to find the volume of the liquid that is displaced, it means we have found the volume of the solid immersed in the liquid. So let us state first of all that the volume of solid immersed in the liquid is equal to the volume of the liquid displaced. So that when you find the volume of the liquid displaced, it will be the same as the volume of the solid immersed in the liquid. But the principle that we are going to use is that the upthrust on the solid is equal to the weight of the liquid displaced. And we know that upthrust on the solid is given by weight in air minus weight in the liquid. And the weight of the liquid displaced is also given by the density of the liquid times the volume of the liquid displaced times gravity. So we want to make volume of the liquid displaced the subject. We are going to get mass of the solid in air minus mass of the solid in the liquid divided by the density of the liquid. So if we know the mass of the solid in air, which we know, and the mass of the solid in the liquid, which we know, divided by the density of the liquid, which we don't know, we can now find the volume of the liquid displaced. Our task here now is to find the density of the liquid and come and substitute the values into this formula. So let's take good notes of this particular formula. So to find the density of the liquid, we have been given the relative density of the liquid. So we know that relative density of the liquid is equal to the density of the liquid divided by the density of water. Making density of the liquid a subject, we have relative density of the liquid multiplied by the density of the liquid. So substituting the figures, we have 0.08 multiplied by 1.0 grams per cubic centimeter. And this is giving us 0.08 grams per cubic centimeter. So now that we know the density of the liquid, let's substitute it into the formula. So the volume of the liquid displaced will be equal to 200 grams minus 160 grams divided by 0.80 grams per cubic centimeters. 200 grams minus 160 grams will give us 40 grams divided by 0.80 grams per centimeter cube. And when we compute this, we are going to get 50 cubic centimeters. So the volume of the solid immersed in the liquid, 50 cubic meters. Now let's take our third question. It reads, a solid weighs 0.04 newtons in air and 0.02 newtons when fully immersed in a liquid of density 800 kilograms per cubic meters. What is the volume of the solid? And the acceleration due to gravity has been given as 10 meters per second squared. Alright, so let us put down the details of the question and now analyze the question. First of all, we have been told that the weight of the solid in air is 0.04 newtons. Now it is being fully immersed in a liquid, and the weight of the solid in the liquid is 0.024 newtons. Once again, we expect that the weight will reduce because of upthrust. The density of the liquid is given as 800 kilograms per cubic meters. The question is asking us to find the volume of the solid. Now, since the solid is fully immersed in the liquid, the volume of the liquid that will be displaced will be equal to the volume of the solid. And so when we find the volume of the liquid that is displaced, we have found the volume of the solid. And since the solid is being fully immersed in the liquid, we expect that upthrust will be experienced by the solid. So we can write that the upthrust on the solid is equal to the weight of the liquid displaced. And this is the first thing we have to know. We already know that the weight of the liquid displaced is given by the density of the liquid multiplied by the volume of the liquid displaced multiplied by the acceleration due to gravity. We also know that upthrust on the solid is given by the weight in air minus the weight in the liquid. So by making the weight of the liquid displace the subject, we are going to get the weight in air minus the weight in the liquid divided by the density of the liquid multiplied by acceleration due to gravity. We have all that we need. We just have to substitute in the value. So let's substitute. We are going to have 0.04 newtons minus 0.02 newtons divided by 800 kilograms per cubic meters multiplied by 10 meters per second squared. 0.04 newtons minus 0.02 newtons give us 0.016 newtons. And we know that 1 newton is the same as kilograms meter per second squared. This will be divided by 8,000 because 800 times 10 is 8,000. And then we are maintaining the unit as kilogram per cubic meters multiplied by meter per second squared. When you compute this, we are going to get 2 times 10 exponent minus 6 meter cubed because we are finding volume. So this is the volume of the liquid displaced, and it is equal to the volume of the solid. Let's take our last question for this tutorial. A solid of mass 1.3 kilograms suspended by a spring is completely in water. If the tension in the spring is 6.0 newtons, calculate the upthrust on the solid, volume of the solid, the density of the solid. the density of water is given, and the acceleration due to gravity is also given. So an object is being suspended by a spring, and later it's immersed completely in water. When it is being completely immersed in water, the tension in the spring or the reading of the spring is 6.0 newtons, which means that while it was in air, the reading must be more than that. So let us continue to solve the question. We know that the mass of the solid in air is 1.3 kilograms. Now let's use it to find the weight of the solid in air. It will give us 1.3 kilograms multiplied by the acceleration due to gravity, which is 10 meters per second squared. And this is going to give us 13.0 newtons. The weight of the solid in the water is 6.0 newtons. Our first task is to calculate the upthrust on the solid, which is very simple because we know that upthrust on the solid is equal to weight in air minus the weight in the water, which is 13.0 newtons minus 6.0 newtons, giving us 7.0 newtons. So this is the upthrust on the solid. The second question is for us to calculate the volume of the solid. Throughout our presentation today, we have looked at how to find the volume of the solid. And it's the same thing we are going to do here. We know that the volume of the solid will be equal to the volume of the water displaced. In this case, the solid is being completely immersed in the water. Volume of the water displaced will be the same as the volume of the solid. To find the volume of the solid, we have to find the volume of the water displaced. And with that, we also have to use the concept of upthrust. We know that the upthrust on the solid is equal to the weight of the water displaced. Upthrust is being calculated, so we substitute the value there to be 7.0 newtons. Now we know that the weight of the water displaced will be equal to the density of the water multiplied by the volume of the water displaced multiplied by the acceleration due to gravity. Now when you make weight of the water displaced and substitute in the values, you are going to get weight of the water displaced is equal to 7.0 newtons divided by 1000 kilograms per cubic meters multiplied by 10 meters per second squared. And this is going to give us 7.0 times 10 exponent minus 4 meter cube. So this is the volume of the water displaced and is the same as the volume of the solid. Now the last part of the question is for us to calculate the density of the solid. And to calculate the density of the solid, we know that density is equal to the mass divided by the volume. Now the volume of the solid is the same as the volume of the water displaced. And so we can say that the density of the solid is equal to the mass of the solid divided by the volume of the solid. Substituting in the figures, we are going to get 1.3 kilograms divided by 7.0 times 10 exponent minus 4 cubic meters. When we compute this, we are going to get 1.86 times 10 exponent 3 kilograms per cubic meters. And this is the density of the solid. This brings us to the end of today's tutorial. Thank you for your time. We encourage you to share the video, like it, and also subscribe.